Welcome back to our machine learning series, which is moving slower than the development of GTA 6.
Oh my god, bro.
Oh, hell no, man.
But don't worry, you don't need to watch the previous videos to follow along with this one. Still, if you want to dive deeper into other machine learning concepts later, they're all there waiting for you. So, to begin, what is feature engineering? In machine learning, feature engineering is all about making your data more useful. Think of it like prepping your ingredients before cooking. It's not just about what you have, but how you use it. In essence, feature engineering involves creating new features, transforming existing ones, selecting the most useful features, or encoding features so your model actually understands them. In today's video, we'll focus on feature creation, and in future episodes, which I promise will arrive before 2050, we'll cover the other three. Feature creation is all about building new features from the data you already have, helping your model better understand the problem it's trying to solve. Let's take a look at this first example, BMI from height and weight. Let's say you are trying to predict whether someone has diabetes. You've got height and weight in your dataset. Individually, those values don't say much, as a high weight doesn't automatically mean poor health, as taller people tend to weight more. But what if we combine them? That's where BMI, which stands for Body Mass Index, comes in. A simple formula really. BMI is the weight divided by the height squared. It gives you a rough idea of whether someone is underweight, overweight, or somewhere in between. Is BMI perfect? Nope, but it provides a clearer signal than height or weight alone. Here is a quick Python snippet using fictional data to create a BMI column. Another example is calculating age from date of birth. Now imagine you have a dataset full of birthdays. That's great. Of course, if you are planning surprise parties. Otherwise, not so great for a machine learning model. Instead, we can calculate age as today's date minus date of birth equals the age. Now your model knows if someone is 50 or 15, which is much more useful for predicting shopping habits, health risks, or even insurance rates. Example 3 is total price from unit price and quantity. You're looking at shopping cart data. You have unit price and quantity. Rather than making your model do the math, just multiply them, getting the total price. Now the model can focus on spotting big spenders or bargain hunters without doing mental gymnastics. Example 4. Speed from distance and time. Let's say you're working on traffic prediction. You know how far a car went and how long it took. On their own, not super helpful, but if we were to calculate speed, which is distance divided by time, now the model knows whether someone was cruising at normal speed or filming the new Fast and Furious movie. Example 5 is getting text length from a message. Machine learning models don't understand text. They only understand numbers. Yes, we'll cover fancy techniques like TF-IDF and bag of words in future videos that convert a text to numbers. That is, of course, assuming that I don't lose my sanity first. considering the fact that the top video in the series has 94 views, it's a possibility.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
But for now, we'll cover some simpler approaches to do the same thing. So you're analyzing customer reviews. Some say just great, others go full dramatic novel. So you can count the words, as more words indicate strong feelings, fewer words, maybe the client just wanted a refund. To do this, you can calculate the following command. In this command, df.text.str.split splits each text into a list of words. .str.lan counts how many words are in each list. The result is stored in a new column called word count in your data frame. And here we converted the text column, which is a string column, to a column containing the number of words, which is an integer column. You can also calculate the text length in characters, the number of unique characters, the number of unique words, or any other basic text stats you can think of. And here is a pro tip for you. Once you've extracted your numbers, remove the original text column before feeding it to your model, because again, models don't take raw text as input. Example 6 is date and time features. Here is a twist bigger than the one in 7.
What's in the box?
Okay, maybe not that big, but still. Machine learning models don't understand date or time either. So if you have a column like datetime, you'll want to break it down. First, convert it to a datetime object using pd.toDatetime in Python. Then you can extract the year, the month, the day, or the hour, and maybe even a column that checks, is this date a weekend? Suddenly, your model knows that people behave differently on Monday mornings than Saturday nights. Not bad, right? Final thoughts. Here are some things to consider when creating features. First, there is relevance. Make sure your features actually help solve the problem. More data isn't always better. Also, there is scaling. You need to always put numbers on similar scales, especially for models like k-nearest neighbors or support vector machines. Also, consider overfitting. Don't get too fancy. Over-engineered features might work great on training data, but crash on real-world data. Finally, consider data leakage. Never include information your model wouldn't realistically have at prediction time. That's it for feature creation, turning raw data into useful data. In the next videos, we'll cover transformation, selection, and encoding, as long as the internet, coffee, and my sanity holds up.